I built a custom off-grid solar electrical system for my DIY school bus conversion, and I'm going to show you how I did it. Hey everybody, my name is Jaden. I'm currently converting this 40-foot school bus into my full-time tiny home on wheels, documenting the entire thing here on YouTube on this channel. So if you like that kind of thing, make sure to hit subscribe so you can keep up with all the progress I'm making on the bus. In this video, I'm going to walk you through my off-grid solar electrical system that I designed and built all by myself. I'll go over each component, its function within the system, how much each component costs, as well as a full pricing breakdown at the end of the video, so make sure to stick around for that. I'll also go over wire sizes that I used, fuse sizes that I used, as well as methods that I used to connect each component within the system. Now, a couple disclaimers before we get started. First and most importantly, I am not an expert. In any sense of the word, I have no experience in electrical work whatsoever prior to this project, so take that into consideration when watching this video. Now, I've done my fair bit of research, months and months and even more months of research, planning, thinking this through, and making sure I was doing everything as safe and correctly as possible. With that being said though, I'm still not an expert. I'm not a professional. So don't take anything in this video as professional expert advice. Be sure to do your own research before trying this at home. Disclaimer number 2, this is my custom built electrical system, meaning that it may not be what you need or want in your van, school bus, RV, boat, whatever your off-grid application is. It may not necessarily work for you, or maybe it will. Just make sure you do your own research prior to designing and building your electrical system, and make sure to consult a professional if you're ever confused about anything with your own build. Electricity is nothing to play around with, and you want to make sure that you're doing everything correctly, and you make sure that you feel comfortable if you're going to be doing it yourself. So if you don't feel comfortable doing it yourself, make sure to hire a professional. With that being said though, if I can do this, I'm certain you can do it as well. So I think that gets all the disclaimers out of the way. Let's start going over this system. I think the best way to start is on the roof. On the roof of my DIY school bus conversion, I have 6 410 watt Panasonic solar panels providing 2460 watts of solar for my system. These panels are wired up in a series parallel configuration, with the forwardmost 3 panels in one series and the rearwardmost 3 in another series. Those 2 series are then brought together in parallel. This means that my solar array is delivering power at about 140 volts and 21 amps when pulling at max capacity. Now, from what I understand, these are pretty high quality panels. I don't have any frame of reference to use when comparing these panels to others because I haven't had any experience with other panels, but I do know these panels have a pretty high modular efficiency compared to other panels on the market. I believe the modular efficiency of these panels are around 22.5% to 23%. How much of a difference those modular efficiency percentages make, I truly do not know, but I do know the bigger your system, the more of a noticeable difference there will be. And with 2460 watts of solar on the roof, I feel like there would be a good chance that I would notice a difference if I had a lower modular efficiency on my panels. Now, if you're curious about how I mounted those panels, I do have a separate video right here that you can go to on my channel going over the entire mounting process if you like the way I did it with those extruded aluminum rails. That's it for the solar panels. Let's hit the back of the bus for the rest of the system. Let's start with the battery bank. My battery bank consists of 3 48 volt 100 amp hour batteries. These are LifePower 4 server rack batteries from EG4. This gives me a battery capacity of 300 amp hours at 48 volts, or a little bit over 15 kilowatt hours of battery storage, which for a mobile application is pretty beefy in terms of battery storage. These batteries talk to each other via these COM ports. There's a COM 1 and a COM 2 port. And to hook up these batteries in parallel with these communication cables, you just hook the COM 1 from one battery to the COM 2 of the neighboring battery and follow suit until you get to the final battery in your bank. Then on the first and last battery of your bank, you put these terminal resistors in the open COM port and you're good to go. For my fusing, I put a 300 amp MRBF fuse with an MRBF fuse holder on the positive terminal on my master battery. The positive connection to the rest of my system then stems from that terminal to my links distributor, which I'll get to in just a minute. The negative connection to my links distributor and the rest of my system comes from my first battery in the bank. To connect these batteries together, I used a jumper wire method using 2-watt positive and 2-watt negative cabling. I also used 2-watt positive and 2-watt negative cabling to connect my battery bank to the rest of my system. And finally, I used a 2-watt negative cable with a 2-watt by 1/4 inch wire lug to connect my battery bank ground to the Lynx distributor ground stud and then to my chassis ground, which I'll cover in just a few minutes. Now, a couple more things to note about my battery bank. First off, you may notice that I don't actually have a master battery disconnect switch. And the reason for this is, one, I had a really difficult time finding a switch that was actually rated to a high enough voltage for my system. You know, a lot of switches out there will say that they're rated for a max of 48 volts, but those are actually nominal ratings and would not be appropriate for my system. But if anyone out there knows of a good battery disconnect switch rated from 60 to 80 volts, please let me know in the comments. I would love to look into that. Second, each battery has an individual 125 amp, 60 to 80 volt rated breaker on it, on top of the power on-off switch. I've tested these breakers with the battery still on, and shutting them all off, which takes me about 1 or 2 seconds, immediately shuts power off from the rest of the system while leaving the batteries on and running. Now, obviously, this is still not the safest or quote-unquote up-to-code option, but unless I can find a better option that will work for this voltage, or an inspector tells me that I basically need to get one to register and insure this thing, this is what I've got, and it's worked great for me so far. Second, if you know anything about these batteries in particular, you know that their intended installation method is to install within a server rack with a positive and negative bus bar to wire your batteries to. Now, the manual only talks about using jumper wires like this in one short note at the bottom of page 14 that basically says you're to use a properly sized bus bar and not jumper wires to connect these batteries in parallel, or there will be issues with inconsistent charging and discharging. Now, since I sized up these cables pretty significantly from the 4-gauge wires provided by the manufacturer and stemmed my positive and negative battery connections from opposite ends of the bank, I do feel comfortable with this method. So far, haven't seen any problems with inconsistent charging or discharging, but only time will tell. Of course, though, my recommendation would be to follow all manufacturer recommendations if you're doing this yourself. So that's it for my battery bank. Let's go ahead and head to the next thing. Next, let's talk about the charge controller. The charge controller I have is from Victron. It is the Smart Solar Charge Controller MPPT 250-100. The 250-100 means that this can take in an input of up to 250 volts and 100 amps. So as I mentioned before, with my solar array on the roof, I'm delivering power at about 140 volts and about 21 amps, so well within the range that this charge controller can handle. This thing's entire job is to basically convert that 140 volts that is taking in from the solar array on the roof down to a chargeable voltage for my battery bank, which is about 52.5 volts. This charge controller can be monitored via Bluetooth on the Victron Connect app, as well as connected to the Serbo GX via a VE Direct cable. For my system, the connections are as follows. The incoming wire are 10-gauge PV wire with a 10-gauge insulated ferrule and 2 screw terminals, a positive and negative screw terminal for the PV side. So this side of the charge controller takes in the wires coming directly from the roof solar array. The battery side of my charge controller has 2-gauge positive and 2-gauge negative wire with 2-gauge ferrules on each, also inserted via screw terminals with a positive and negative screw terminal here on the left side. There is also an equipment ground screw on the left side of the charge controller that takes a 1/4 inch wire lug. This equipment ground connection in my system is connected to the equipment ground on the MultiPlus. The wires coming from the battery screw terminals on the charge controller go directly down to the Victron Lynx distributor, which I will go over shortly. I think now would be a good time to go over the last week or so of solar charging and show you what I'm seeing on the Victron Connect app with the charge controller. Now within the Victron Connect app, you can see all your devices that are connected via Bluetooth. For some reason, I have 2 Serbo GXs, not entirely sure why. I have my Smart Shunt and I have my charge controller that individually connect via Bluetooth without having to connect to the GX. Within the Serbo GX though, I also have my MultiPlus that can't individually connect via Bluetooth, but we're worried about the charge controller right now. So we're gonna click on the Smart Charge Controller, and we can see currently we're pulling in 0 watts. It is, as you can see, maybe see, it's pretty dark, rainy, and cold outside, so to be expected. So if we go over to history, we can see the last 6 days of charging since I hooked these babies up. Now you can see the first day right here, I had them charging for about 2 hours and 38 minutes, and this was on a pretty overcast, cloudy, cold day, and it was kind of later in the day when I turned this on, so this is to be expected. A pretty small amount of charging, though it's not too bad, about 380 watt hours, so not terrible. The next day I had it hooked up for the entirety of the day, and you can see this is pulling in charge for a little over 13 hours, providing just about 1.7 kilowatt hours of charge. Now this day was overcast the entire day, And being able to pull in almost 2 kilowatts of charge from an overcast day, in my book, that's not bad at all. But here's where we get to the fun stuff. On the third day, this was a beautiful, beautiful sunny day. Not a cloud in the sky, really. I mean, there were a few, but nothing really. And you can see I had the charge going for about 11 hours and 52 minutes, pulling in nearly 7 kilowatt hours of battery storage. That's crazy. That's almost half of my battery bank storage in just one day. Awesome. Now in the next 4 days, we start to see some other colors on these bar graphs here, and I'll show you what these are. So if you click on the next day, you'll notice that in the white, the bulk, we had 7 hours and 3 minutes of charge, which is 63% of the charging. And then we move up to this kind of grayish blue, faded blue color that's labeled ABS, which is short for absorption. And we were in absorption for about 8 minutes. That made up 1% of the charging for the day, and the rest of the day was in the float stage for about 4 hours and 2 minutes, making up 36% of the time. Now the differences between these three are as follows. So in bulk, the charge controller is not limiting the voltage that's coming in from the solar panels on the roof. So it's taking as much as it can possibly get. Your charge controller is going to be in bulk when it's not really close to 100% charge, so it doesn't need to manage the voltage coming in to avoid damage. The absorption stage is where you start to get closer to a fully charged battery, and it starts limiting the voltage a little bit that's coming in. And then when you get to the float stage, you're essentially at 100%, and it's pulling in maybe a few watts here and there just to keep it topped off on your battery storage. So you can see a little over 7 hours in on my 4th day of charging, I was up to full on my battery storage. And the next few days, I've really only gotten into bulk for a little bit of the day. So that's some pretty cool data that you can see directly on your phone, or if you have something like the Touch 70 from Victron or some kind of touchscreen display, you can also see it physically with the Servo GX. Pretty cool. While we're on the topic of solar charging, let me show you my DC isolator switch. Here is my DC isolator switch. It's in line between the positive and negative wires coming from my solar array on the roof through to my charge controller. This thing's whole job is to shut off power or turn on power coming in from the solar panels on the roof. So if I need to service anything, all I need to do is turn off my batteries, turn off the breakers on my batteries, as well as flip this switch so I don't have to get up on the roof and manually disconnect the MC4 connectors to keep power from coming in to the bus. Now, to be completely honest with you, I don't have my screwdriver or drill here with me, and I don't really feel like getting it, but I'll show you a picture of what the inside looks like right here. This DC isolator switch can take up to 2 different solar arrays. Basically, it just has 4 screw terminals here on the top and 4 screw terminals here on the bottom, and you just wire your wires straight through. So your positive would go into one. So let's say the negative goes into the far right terminal, the positive goes into the next. Then you just follow suit straight down and wire your negative into the far right and your positive into the next. For me, I use insulated ferrules here as well, just to make the connections easier, but you do not need to use ferrules if you do not want to or you don't have them. Now, I actually had a rough time with that isolator switch, not because of the switch itself, which is what I thought, but actually my MC4 connectors that were coming into the bus were being pulled on so hard that they were basically separating the actual pin on the inside of the connector, making it to where the pins weren't touching each other, so there was no power being delivered. And I had to make basically 3 or 4 different sets of MC4 connectors to make sure that they would stay tight, basically. So I finally got to work. But if you get that kind of switch, or any switch really, and it's for some reason not pulling in any charge when you hook it up, maybe try your connections on the roof. All right, let's move on to some AC 120 volt stuff with the MultiPlus. Now, this is the Victron 48 volt 5K MultiPlus 2 inverter charger. This thing's whole job is to take the 52.5 volts from my battery bank and boost it up to 120 volts to power all of my AC loads, like my outlets, mini split, washer dryer combo, or anything else I have on 120. So underneath the hood here, you can see all the different connections that I have made, and I'll work from left to right going over which connections do what. So on the far left, we have the AC output wires. This is 6 gauge triplex marine grade wire, and this wire stems from the AC out 1 to my AC distribution panel, which I'll get to in just a moment. On that note, this MultiPlus has two AC output opportunities, so if you wanted to, for some reason, use both AC outputs, you could do so. For me, I'm just using one AC output. The next connection here is the AC input. Now this is coming directly from shore power. This is 10 gauge triplex maroon grade wire, and both of these triplex wires have insulated ferrules and screw terminal connections on there. The connections are labeled as neutral, ground, and hot for ease of connection, and are extremely easy to do. The next connection here is the ground stud terminal. Now this ground stud terminal has the equipment ground from my charge controller that I just showed you, as well as the individual connection for the actual MultiPlus ground, and that goes to the Lynx distributor ground, which again I will cover shortly. This blue cable right here is an RJ45 UTP cable that is responsible for sending information to the Serbo GX for Bluetooth monitoring. If you want to monitor this via Bluetooth with the Serbo GX, you're going to need an RJ45 UTP cable. And the last two connections right here are of course the positive and negative battery connections. These are 2-aught sized wires, just like I used for the battery themselves. The charge controller ground is a 2 gauge negative wire, and the MultiPlus ground is a 2-aught negative wire. The wire lug sizes that I used for the battery connections are 2-aught by 5/16 inch wire lugs, and I used 1/4 inch wire lugs for the ground connection. Now's a good time to check out how we can monitor the MultiPlus on the Victron Connect app and what information it shows us. So if we go into the Victron Connect app and go back to our Serbo GX, we can see the MultiPlus, Smart Shunt, and Smart Charge controller. We're going to hit the MultiPlus, and we can see currently it is not pulling in any charge from shore power. It is inverting at 1 watt because nothing's hooked up to it, and you can see that there's 1 amp flowing from the battery side of things at around 53 volts. The detailed tab shows you a little bit more information. You can see what state it's in, you can see if the AC input, which is the shore power, is connected or disconnected, and you can see the voltage, wattage, current, frequency, everything you need to know right here in the app. Now the unfortunate thing is about the MultiPlus, you can't actually program it within the app. So if you go into the settings here, you'll see settings are disabled. To access the settings, connect locally using an MK3 to USB interface, which they do include with the MultiPlus. However, I just haven't programmed it yet. But you're gonna need to program this thing for at least a couple things. One main thing is to limit the current that it can draw in from shore power. If we go back to here, you can see that the Okay, you guys saw me learn something just now in absolute real time. Oh man, that's funny. I did not realize you could do that. That's crazy. Well, okay, so you can oh man. Okay, so you can in fact change the amperage that comes in from shore power on the app. I guess you can't do everything else though, but that's all that I really cared about, to be honest. Oh, that is funny. Thanks guys, thanks for helping me. Okay, well, see here, you can change your input limit. So if you have 50 amp shore power, you can put it, I think I've heard it recommended that if you have like 50 amp shore power, you actually put it at like 45 amps or something. For me, I have 30 amp shore power, so I would put it at probably like 20, 25, 28 amps or so. However, if I want to charge it from something like the garage outlet here, which is a 20 amp circuit, I would put it at like 15 amps, maybe even a little bit less, just to make sure that I don't trip the breaker or cause any damages or anything. That's super cool though, that you can do it on the app. That's awesome. I did not realize you could do it. That's pretty sweet. I don't know who's trying to pull in 100 amps from this thing, but surely that is not me. Well, anyway, that's what you can see with the Victron Connect app on the MultiPlus side. Let's move on to, well, let's stick with AC and move on to the AC distribution panel. Now, the AC distribution panel that I used is this one from Progressive Dynamics. It has a little nice push to open access port to access all of your, breakers. The breakers that I'm using are the Square D Homeline breakers. I have a 30 amp main breaker and 20 amp tandem breakers for these 3 spots, and then a 20 amp single pole breaker right here on the last. This is a nice low-key sleek design for an AC distribution panel, and it offers up to 8 branch circuits on one side of the panel, so 4 spaces equaling up to 8 if using tandem breakers, 8 circuits. Wiring this thing up was incredibly simple. All you got to do is insert your feed wires from the back of the box wire up the neutral to the forwardmost bus bar on the bottom, wire up the ground to the rearwardmost bus bar on the bottom as well, and then wire up the hot leg of your wire to your main breaker screw terminal that's on the bottom of the breaker. And then just follow suit with all of your branch circuits. Neutral to neutral bus bar, ground to ground bus bar, and hot to that individual breaker's screw terminal. One nice thing about this panel is it's not too deep, so if you have a 3.5-inch wall like I have here, it fits perfectly, as well as it has built-in strain relief on the back for your branch circuit wires, so you don't need to worry about putting that in. It'll hold everything in place nice and tight. Alrighty, that is it on the AC side. Let's go ahead and jump to the DC side again. Alright, so we got a few more stops to make. The next stop is the Victron Orion 48 volt to 12 volt 30 amp DC to DC converter. This thing's entire job is to knock down that 52.5 or 53 volts coming from my battery bank down to a 12 volt appropriate voltage to power all of my 12 volt loads like my lights, my fans, my fridge, my oven lights, my oven ignition, water pump, propane water heater, and also my toilet fan. So this thing's got a lot of work to do pretty consistently, but setting it up could not be easier. To hook up wires to this Orion, it's the same exact method we've used for the charge controller in that it's screw terminals on the bottom. So on the output side, I have 6 gauge positive and 6 gauge negative wire. And from the input side, I also have 6 gauge negative and 6 gauge positive wire that go to the Lynx distributor. The wires on the output side go directly to my DC 12 volt fuse block, which I'll show you right now. Also, just a quick note out there, this little wire bridge right here comes disconnected in the packaging, but is necessary to be installed if you want this thing to work. It's as simple as just pushing it in. Sticking with the DC side of things, here is my 12 volt fuse block. So you pop off this cover and you have all of your blade fuse terminals right here. And wiring this thing up was similarly easy to the AC distribution panel. There's a positive input terminal on the bottom corner of the panel on the back side that is just a screw terminal again, so inserting the feed positive wire and tightening it down. The negative feed wire goes to any of the negative spots on the negative bus bar. This particular panel features 2 positive feed wire inputs, meaning that you can stem this off to 2 or more separate panels if for some reason you want 2 different panels in your setup. For me, I'm just using the 1 panel, so just 1 input wire is good on the positive side. The negative bus bar is where all of your negative branch circuit wires go, and the bus bar on the opposite side of the panel is the positive bus bar, and that's where all of your positive branch circuit wires go as well. These spots are numbered and correspond to the same number on the flip side of the panel where you'll insert your blade fuse, and there's also a label sheet on the back of the cover. All right guys, we're almost there. All right, next stop is the Lynx distributor. Now this is a pretty sweet deal here. It's basically just a big positive and negative bus bar wrapped into a neat little package with a computer board in the middle, and it has 4 mega fuse holders. So you can see there are 4 mega fuse holders, one right here, 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 and here. One of them is unused. And what's cool about these is if you need more spaces, you can basically just attach another Lynx distributor onto the end using these end studs right here. And you can basically put as many of them as you want to get your desired number of spaces. For me, I only needed 3. So you have your positive bus bar on top, you have your mega fuse holder slot right here in the middle, and then you have your negative bus bar on the bottom. Now, the negative bus bar also has an extra stud right here in the middle, and that's for your ground connections. So my ground connections here are from the battery bank, the multiplus, and the chassis ground. Now, honestly, if I could go back and do this again, I would prepare to make a longer ground connection from the batteries and separately ground the batteries to the chassis themselves, just to give a little bit of extra space to the ground stud terminal on the Lynx distributor, but I was able to fit it all in and, you know, haven't had any issues with it yet. So working left to right, on the left I have my multiplus wires hooked up with a 200 amp 70 volt mega fuse, and the next slot over I have my charge controller hooked up with the 2 gauge positive and 2 gauge negative wire with a 125 amp 70 volt fuse. And on the far right connection, I have my Orion hooked up with 6 gauge positive and 6 gauge negative wire and a 60 amp 80 volt mega fuse. The only reason there's an 80 volt fuse here and 70 volt fuses here is because I couldn't find a 70 volt 60 amp fuse And as long as it's rated over 58 volts or whatever it needs to be, it's all good. Now, one more connection I have here is on the far right, and it's a positive and negative connection directly from the Servo GX, just making sure that the Servo GX can actually turn on. What's nice about the Servo GX is that you don't need to knock the voltage down to 12 volts or bump it up to 120. You can just attach it to anything from 12 all the way up to 48 volt systems. Now, I'll be the first to tell you, this is not the cleanest job in the world, but it works, and for that I am truly grateful. Like I said, the biggest gripe that I have is, one, I didn't plan my wire runs perfectly. So if I could plan all my wire runs again, I would have made them a lot neater and longer in some cases. And the other thing I would definitely do differently is make a separate dedicated ground connection from my battery bank to the chassis ground. Speaking of the chassis ground, well, I guess let me talk about it because I don't have it on film, but let me talk about it. So I have the chassis ground hooked up to this support rib on the actual bus frame. The chassis ground matches the largest wire size in my system, which is 2 aught, so it's a 2 aught cable going from the link distributor to the connection point. Now, what you're gonna wanna make sure you do is get this following assembly to make your chassis ground. You're gonna want a bolt that's long enough to go through either your wall or both sides of the rib. In my case, I had to drill through 2 sides of the rib. You're gonna need your bolt, you're gonna need a washer, you're gonna need your lug, and you're gonna need a serrated washer. On the other side of the wall, you're going to need a washer, a lock washer, and a nut. And you're going to want to tighten those down pretty aggressively so that you make sure the serrated washer gets a really good connection and there's no paint interfering, there's no looseness or anything of the sort. Making the ground connection was pretty simple. I don't know if I missed anything there. If I did, please let me know. But yeah, it was pretty straightforward. All right, second to last is a very precariously not yet fully mounted Victron Smart Shunt. Now, this Smart Shunt is wired in line with the negative wire coming from the battery bank to the rest of the system, and it monitors battery state of charge, battery output, battery input, anything basically you need to know about your batteries. So you can monitor this thing with Bluetooth with either the Servo GX or just by itself, and it's powered directly from the positive terminal on my battery bank going to the rest of my system. If you want to connect it to the Servo GX like I have it connected, all you need is a VE direct port that goes in right here and connect it to the Servo. Now, one thing that I was surprised about and I find kind of silly is that you need to manually set the state of charge reference for it to accurately display state of charge. So basically, if you get brand new batteries and they come from the manufacturer at somewhere around 50% and you just, wire them up, hook them up to your system, and then hook up the Smart Shunt, the Smart Shunt's going to say it's at 100%, or at least it wants you to, because it can't actually automatically detect the state of charge. Now, that's not a huge deal if you can just fully charge your batteries and then just mark it as full, then it'll have a good reference point. But I don't know, I think it's kind of silly. That's not necessarily a required item, but I wanted it to be able to monitor my battery state of charge. All right, and the last stop off is this Servo GX. Now, like I mentioned before, this is powered directly on these 2 studs on the Lynx distributor and is connected to the Multiplus, connected to the charge controller, and connected to my Smart Shunt. That way I can monitor what's going on in terms of solar charging, in terms of inverting, and in terms of battery state of charge. This thing can also hook up to a touchscreen display, also sold by Victron. I just don't have that because I don't find it necessary if I can see it all on my phone. And that's about it for the Servo. Not much to say there really, it's just a way to monitor your device. Now, I will be the first one to tell you that my system is not the cleanest. It's not the best. It's not the most professionally done, maybe not even the safest. However, it works for my needs. And I did it all by myself. Remember guys, this is not a professional page. This is a fully DIY first timer YouTube channel. Doing all of this for the first time myself, all by myself. So that's a DIY job right there. Just keep that in mind. But it's working great. It's pulling in charge. It's powering all these lights, my Max Air fans, everything I have hooked up to it. It's charging my phone with the outlet that I have very precariously wired over there. I'm not going to show you. But I mean, it's great for me so far. So here's a pricing breakdown of each component and a full price as well. So all these prices that I'm saying are after tax. Keep that in mind. My 6 410 watt solar panels on the roof cost me $2,303.56. My 3 48 volt server rack batteries cost me $3,884.76. My charge controller cost me $662.04. The Lynx distributor cost me $217.57. The Multiplus cost me $1,575.72. The Orion DC to DC converter cost me $217.57. The Smart Shunt cost me $108.32. The AC distribution panel cost me $102.59. The DC distribution panel cost me $70.19. I'm estimating about $700 for various tools required, fuses, wire lugs, ferrules, wires themselves, everything else that's not an individual component. Altogether cost me about $700. And finally, the Serbo GX cost me $267.84. That brings the total cost for everything in my system to $10,100.16. Now, I know that sounds like a pretty steep price tag, and it for sure is. My wallet's been feeling real light the last, well, forever really, but extra light these last few months. Some of you may say this is all overkill and way too expensive. Others of you may think that I don't have enough and I should have spent more. But just remember, this is my custom built, custom designed DIY solar electrical system for my school bus conversion, and it is tailored to me, my wants, and my needs. So just because it works for me, again, doesn't mean it'll necessarily work for you, or maybe it will. So if you want to tackle something like this, here you go. Feel free. The world is yours. I will say one major thing that I may reconsider if I were to go back to square one and do this all over again is to, instead of go with a 48 volt system, go with a 24 volt system. And the reason being, there's just more product selection with a 24 volt system versus a 48 volt system currently. Something like the Orion, for example. The 48 volt to 12 volt DC to DC converter only comes in a 30 amp option. So if I need to power more than 30 amps continuously for some reason on my 12 volt loads, I would need to have another Orion. Whereas for a 24 volt system, there are 24 to 12 volt converters from Victron that can handle a lot more amps. And on the topic of the batteries again, you can find a really cheap, really good quality 24 volt rated battery disconnect switch. Whereas for a 48 volt system, those don't really exist from what I've seen, or if they do, they're wildly expensive and really kind of weird. Now, I'm not saying that I regret this at all. I think I am extremely happy with this system and the fact that I actually got it up and running without starting a single fire. But if I was returning, back in time 6 months to when I started planning for this thing, I may in fact tell my past self to, hey, maybe go with the 24 volt system. It's going to save you a lot of headaches down the road. So just keep that in mind if you're brand new to all this. Maybe tackle a 24 volt system. I will say 48 volt systems are becoming much more common pretty much everywhere. So, some number of years down the road, there's going to be a lot of options as far as products go for 48 volt systems. So a good way to future proof is definitely going with the 48 volt system, but you might find yourself scratching your head and rubbing your eyes and being kind of frustrated as the days go on when you're planning it. But I don't know, to me it's worth it. So there you have it, guys. That's my fully custom built DIY off-grid solar electrical system for my DIY school bus conversion. I think it turned out really great. As you can see, it's powering all these lights here in the bus right now, and it feels good. It feels good for sure. If you enjoyed this video, go ahead and let me know by hitting subscribe so you can keep up with all the progress I'm making on the bus. If you think that I did anything kind of incorrectly or I could have done something better, feel free to let me know in the comments. I do read them all, so I would love to hear your input if you're an expert in this field. With that being said, I clearly have a lot more work to do to make this thing into my tiny home on wheels, so I'll catch you next time.